Located approximately 650 light-years away in the Orion constellation, Betelgeuse is no ordinary star. It is a red supergiant, one of the most luminous stars known, shining with a brightness over 100,000 times that of our Sun. But why is this massive star so significant to us? Beyond its brilliance, Betelgeuse holds deep cultural significance. Its name derives from the Arabic phrase Yad al-Jawz, meaning the hand of Orion. This star has been observed and recorded by ancient civilizations for millennia, guiding travelers and fascinating astronomers with its distinctive red hue, setting it apart from other stars in the constellation. Imagine a single star so enormous that it could overshadow our entire solar system. To put it into perspective, if Betelgeuse were to replace our Sun, its outer edges would extend all the way to Jupiter. How does such a star achieve these colossal dimensions? At around 10 million years old, Betelgeuse is much younger than our 5-billion-year-old Sun. However, its immense size causes it to consume fuel at a far quicker rate, forecasting a much shorter lifespan compared to other stars. This celestial giant, occupying a volume large enough to house over 1 billion suns, is nearing the end of its life cycle. When stars of this size reach their twilight years, they don't simply fade away. Instead, they make a dramatic exit in the form of a supernova, an explosive event of unimaginable energy and brilliance. This type of explosion has the potential to outshine entire galaxies, creating shadows of light that stretch across vast cosmic distances. The last time Earth witnessed such a nearby cosmic explosion was in 1604, before the advent of modern telescopes. The Kepler supernova, visible for over a year and a half, was the most recent supernova observed in the Milky Way. It was so bright that it rivaled other stars in the night sky and remained visible even during the daytime for several weeks. So, what hidden truths do these stellar remnants reveal? Ancient records from civilizations, including those of Chinese and European astronomers, documented the appearance of new stars, giving us insights into the violent ends of massive stars. Remnants of these explosions, seen today as expanding clouds of debris, continue to provide us with valuable data about the catastrophic ends of supergiant stars. Although supernovae have been rare for observers on Earth, imagine an event so powerful that it rivals the brightness of the full moon, casting shadows on Earth at night and possibly being visible in daylight as well. The radiation emitted by such an event would be so intense that it could charge our atmosphere, potentially disrupting satellite communications and even affecting the environment. Betelgeuse, with its erratic dimming patterns, seems to be preparing for just such an explosive spectacle. Could we be on the verge of witnessing one of the most extraordinary events in the universe? Just recently, between October 2019 and mid-2023, Betelgeuse underwent a remarkable transformation that captured the attention of astronomers and stargazers alike. Known as the Great Dimming, this change in the star's brightness, which had been relatively stable for centuries, began to drastically decrease. This sudden dimming was so noticeable that even casual observers could see the change when comparing Betelgeuse with other stars in the Orion constellation. This implies that we may not be centuries away from witnessing Betelgeuse's supernova. It could happen within the next few decades or perhaps even sooner. By April 2023, astronomical observations indicated that Betelgeuse had returned to its normal brightness levels, leading many to believe that the dimming period had ended. In a stunning twist, over the following months, Betelgeuse's luminosity surged by an unexpected 50%. While fluctuations in brightness are common for variable stars, such dramatic shifts are highly unusual for a star like Betelgeuse, which typically exhibits consistent cycles of luminosity. This abrupt increase in brightness thrust Betelgeuse back into the spotlight, raising questions about what caused this unexpected change. Why did this once predictable star suddenly undergo such dramatic fluctuations? Stars are not simply fixed points of light in the night sky. They are dynamic, evolving entities with life cycles, behaviors, and mysteries of their own. For many stars, changes in brightness occur in predictable patterns, much like the seasons on Earth. Betelgeuse had maintained a relatively steady 400-day luminosity cycle throughout much of its existence. However, with the Great Dimming, it appeared to defy this established pattern, challenging our understanding of stellar phenomena. Now, you might be wondering, are we on the brink of an astronomical discovery? While the exact reasons for Betelgeuse's anomalous behavior remain under investigation, an intriguing theory has emerged. This hypothesis involves stellar activity and mass ejection, presenting a fascinating scenario. Imagine Betelgeuse as an enormous volcano, quietly emitting vast quantities of its material into space. Previous observations from the Hubble Space Telescope revealed that Betelgeuse had expelled a massive amount of material from its surface into the cosmos. This ejection, a spectacular event, involved roughly 400 billion times the mass typically expelled by similar solar phenomena, equivalent to several times the mass of our Moon. Such events can lead to the formation of a dense cloud of dust around the star, temporarily reducing its apparent brightness and making it harder to observe. As this dust cloud disperses or is pushed away by the force of the star's radiation pressure, the star's true brightness is revealed once again. This could explain why Betelgeuse returned to its normal luminosity levels after the dimming period. These new developments suggest a star that isn't finished astounding us yet. Many speculate that Betelgeuse is approaching the end of its life. But what exactly is a supernova? A supernova is an explosive burst of energy that can outshine an entire galaxy. This event occurs when a star undergoes a sudden collapse at its core, triggered either by the accumulation of matter from a neighboring star or, in Betelgeuse's case, the depletion of its nuclear fuel. As this fuel runs out, the star's mass collapses inward, setting the stage for a cataclysmic breakdown. But what pushes a massive star like Betelgeuse toward this end? Born from the gravitational collapse of gas and atomic clouds, stars like Betelgeuse begin their lives by fusing hydrogen at their cores. This initial stage, known as the main sequence, lasts for billions of years and forms the foundation of a star's life cycle. As hydrogen reserves are exhausted, the star progresses to new stages, beginning with the fusion of helium. In Betelgeuse's case, this transition results in the formation of heavier elements like carbon and oxygen. Eventually, as the helium reserves are depleted, the star expands into a red giant. Over time, as the star's mass increases, it enters stages of even heavier fusion, each step marked by the creation of increasingly complex elements. When iron forms at the core, it cannot generate the energy needed to counteract the force of gravity, leading to a collapse and ultimately a massive explosion, the supernova. Is Betelgeuse approaching the brink of this explosive end? Recent research from Japan's Tohoku University suggests that the star may currently be in its carbon-burning stage, and its core could collapse within the next few years. However, not all researchers agree. Studies from Hungary's Konkley Observatory suggest that Betelgeuse is still in the earlier helium-burning stage. Despite these differing opinions, one thing is certain: Betelgeuse is destined to become the next supernova in our Milky Way. But when will this happen? The timing remains an ongoing mystery, with estimates ranging from just a few decades to as far as 100,000 years into the future. While scientists debate the exact timing of Betelgeuse's demise, one undeniable fact remains. When it happens, it will be a truly extraordinary event. As we ponder the potential for such a celestial explosion, it's important to consider the broader implications of such an event on our cosmic neighborhood. When Betelgeuse reaches the end of its life, the shockwaves produced by its supernova will impact the surrounding interstellar medium. These shockwaves will create vast regions of ionized gas, enriching space with heavier elements formed during the star's lifetime. This process plays a vital role in the ongoing cycle of star formation and planetary creation. Moreover, the light from Betelgeuse's eventual explosion could serve as a natural laboratory for astronomers studying the life and death of massive stars. By examining the light curve and spectral features of the explosion, scientists can gain valuable insights into the physical processes that occur during such destructive events, refining their models of stellar evolution. But beyond the scientific impact, a supernova could have profound social and cultural consequences. Throughout history, celestial events have inspired artists, writers, and philosophers to reflect on our place in the universe. Betelgeuse's eventual explosion could spark a new wave of creative expression as people across the globe gaze up at the night sky, contemplating the transient nature of existence and the vastness of the cosmos. On a practical level, the radiation from a nearby supernova could have significant effects on our technology.